All right. Hello and welcome to the lab practical practice walkthrough video. So I'm going to be working through all of the questions on the lab practical practice, the practice exam. I'm going to be stopping every now and then to tell my cats to stop fighting. But hopefully we should be able to move this pretty quickly. So I have my arc window open. I have created a new, how do I make this go away? Can I make this go away? Hide video panel. No, hide floating meeting controls. There we go. All right, so I've created a new arc document. I have already added the folder. Thought I added the folder. I did add the folder, right? Nope, didn't add the folder. So I'm going to add the folder that has the lab practical practice in it. This is the one that I downloaded from the Canvas. This has all of the data in it. So I'm going to start by bringing in all of the part 2 data. And we can get started. So question 1 is, how many culverts are there in this area? So for this one, we are just going to use the attribute table for the culvert layer, open this up. And we can see down at the bottom here, it says 0 of 135 selected. That is how many objects are in this feature layer. So the answer for this one is just 135. Very simple. You can also scroll all the way down in here if you want and check the row number 135. Remember the FID, which is the feature ID, starts at 0. So you can see up here, 1 is 0. So that is always going to be less than the actual number of features. Next question, question number 2, how many culverts are made of metal? So for this one, we are going to use select by attributes, open that bad boy up. You can also open select by attributes through the analysis, through the map tab right up here. But if you're working specifically in one layer, you can click it over here and it'll automatically know that you're trying to work with the culverts data. We are adding a new selection. We are interested in the material of the culverts, and we would like for it to be equal to metal. Do that, hit apply, and the selection is applied. We can look down here and it says 108 of 135 selected. You can also hit OK if you want this to go away. It'll do the same thing, but that will disappear. And now we can see where our metal culverts are on this map. Next question, how many metal culverts are 24 inches wide? So for this one, we can either start with this selection that we already have. And if we're going to do that, we're going to go back into select by attribute. Rather than new selection, we are going to select a subset from the current selection. Add to might seem like the correct option, but what this actually does is keep everything that has already been selected and add into it anything that is not selected that also has a width of 24 inches. So we don't want that. We want a subset. We want to look at what is already selected and only show the ones that are 24 inches. So add a new clause. We are going to look at the diameter. We want the diameter to be equal to 24 inches and hit apply. And we have 5 remaining. So that is our answer here. There are 5 culverts in this area that are both made of metal. Their material is equal to metal and their diameter is equal to 24 inches. Hit OK. We can also do this all in one step if you've already cleared your selection by going to select by attributes, not having. We're going to have a new selection this time, and then you just need to enter both of these. Remember, you can add a new clause to your selection just by clicking this, and if you add too many, you could just get rid of it. Say apply, and there we go, 5 again. Question number 4, how many culverts are located within 100 feet of a stream? So let's clear our selections, and for this one, we are going to use our select by location. Our input features are going to be culverts. We are interested in how many culverts are within that distance of a stream. So that means we are trying to, our final number is going to be a number of culverts. If in this case, when you are selecting from something like culverts, in this case, that is going to be your input feature. Your selecting feature is going to be your streams. So the selecting feature is what we are looking at to decide whether or not we are going to select a particular culvert. So we are going to keep it as intersect, and we are going to set our search distance as 100 US survey feet. You can also do within a distance, but it's easier to just do intersect. That's your default one. US survey feet, you could do international feet, I guess, if you wanted. The difference between them is incredibly small. So stick with survey feet because it was already filled in there. Hit apply, and we have 40 culverts that are within 100 feet, 100 US survey feet of a stream. And again, we can find that by looking down here at our attribute table for the culverts and seeing how many objects are selected. So hit OK on that one. Question number 5, of the culverts within 100 feet of a stream, how many are made of metal? So for this one, again, we're going to keep this selection that we already have. If you cleared it, go back and redo that select by location. And we're going to go into select by attributes. Again, we would like to be using select subset from the current selection. We are only interested in these culverts that are within a distance from the streams. It kept my old expression. They will not always do that. I'm not sure why it's doing that here. We're not interested in the diameter in this case. We're just interested in the material, which is equal to metal. So I'm selecting culverts from those that have already been selected where the material is equal to metal. And we'll hit apply. And we have 29 culverts. And let's see, question 6 is describe your methods for answering question 5. We just did that. I showed you, so we don't have to go over that. All right. Next up, question 7. What material is the culvert with the maximum diameter located on Barniston soil? What diameter is that culvert? So we're going to clear our selections once again. Let's start by opening up our soils. Oh, I lied. We actually don't need to do that because this already has... no, it does not. I lied. So we do need to go into our soils table, look at our soil names. I can see Barniston in there. So what we are going to start by doing is selecting by attributes in our soils table. And we are just interested in soils where the soil name is equal to Barniston. We're going to hit apply. And you can see that there are 26 of those selected. We can see them in here. If you want to double check, you can look in and see, yes, they are all Barniston. So now what we need to do is apply a selection onto our culverts using select by location. So, like we talked about before, when we are choosing our input feature, that should be the feature that we are interested in having our answer be. So because we are interested in a number of culverts that are close to soils, but we're interested, our final answer is going to be about a culvert. Our input feature is going to be our culverts. We're looking at intersection, and the selecting feature is our soils. We do want to use the selected records here. These are the Barniston soils. Those are what we are interested in. So let's hit apply and see what happens. We have 10 of these culverts that are over top of the Barniston soil. I'm going to close out of this bad boy. So rather than having to be annoying and scroll through to find all of these ones that are selected, we can use this feature that lets you only view the selected records. Here we are, and then in order to see the largest diameter, we're going to right-click on diameter and sort descending. And there we go. We can see that this culvert is 48 inches, and it is made out of metal. Beautiful. It is also rusty and remarks 27 Creek. I don't know what that means. Alrighty, question 8, describe your methods. Watch the last 2 minutes of the video. There you go. Question number 9, what are the names of the soils underneath the 1200 road? What percentage of rock fragments do each of the soil names contain? So let us clear this selection one more time. Hello, my cat wants to be on my lap, but there is no room for her up here. So we are interested in the soils. We are interested in the roads in this case. So our soil doesn't say anything about roads, so we're going to need this roads layer. Let's open up that attribute table and look, there's road names. I love it. So we are going to select by attributes here. We are interested in our road names. So roads, new selection, where road name is equal to 1200 road. Ta-da! And then we'll hit apply. All right, and we can see that there's 7 selected. So the reason that we have to do this selection is because this 1200 road is actually made up of a number of different line segments. So we want to make sure that we have all of those selected. So next up, we are interested in our soils, but we are going to be doing a select by location because we are only interested in the soils that are coming into contact with this particular road. So going to select by location. Again, we're interested in the soils. Our answer has to do with the soils, not the roads. So our input feature is going to be our soils, and we are selecting by the roads. Again, using those selected records. No search distance. We are only interested in those that are right on top of each other. So let's hit apply. And we have 5 soils selected. So hit OK, and let's navigate on over to our show selected records. And we have 3 different soils that are present underneath this road. We have Barniston soil, Wilkeson soil, and Bellingham soil. So rock fragments, how do we find out about that? Well, it just so happens we have a standalone table that's called rock fragments. If you wanted to, you could certainly join these 2 tables. That might make it a little bit easier to go in and check. But in this case, because we only have the 3, I'm just going to be a little bit lazy with it and take a look in the rock fragments table. And you can see that Barniston is 58% rock fragments. Bellingham is 0% rock fragments, and Wilkeson is 25% rock fragments. So those are our answers there. All right, next up, question 11, which is the last one for part 2, which is also the first, yeah. All right, so question 11, what is the total distance in kilometer of gravel light-duty roads in the study area? So we're looking at roads. Let's clear our selections. We're going to use a select by attributes here. And we are going to say, okay, we got a couple of, we are interested in roads where the surface is equal to gravel, where the, is that use or use class for light duty roads? Let's see. Use has light duty on there, so use is equal to light duty. And those are the only 2 attributes that we're interested in here. So apply. All right, so now we have selected all of our gravel light duty roads. I apologize, the heat in my apartment just came on and it is sometimes a little bit loud, but it's really cold in here. So we can scroll through, we see that they're all gravel light duty. There's 63 records in there. So since we are interested in distances, we're interested in the total kilometers of road that fits these specifications. We are going to add a new field. This field is going to be called length km. And we're going to set it to be a float field because we're interested in decimals. Save that new field. Wait for Arc to do all of its thinking while it creates a new field. All right, and head back over to roads. There she is, length kilometer. It is currently 0 because we have not calculated our geometry yet. We have to tell Arc what to do with this new field. So something interesting about this is because we have an existing selection, it should only select or it should only calculate the geometry for what has already been selected. Of course, okay, there we go. I was gonna say, of course, if this ever opens. So we can actually tell it, do we want to use the selected records or not? In this case, let's use them. It makes our lives a little bit easier. We are interested in the length. The length unit we're interested in is kilometers. We are ignoring the coordinate system box for right now. We are looking at a very small area of land. We do not need to worry about the curvature of the earth right now. And also, we haven't talked about coordinate systems and projections in class yet. So let's hit OK. Beautiful, beautiful. And as you can see, it only is showing you, it's only done the calculations on these selected records. So the ones that were not selected are still showing a length of 0. So let's right click on here and go to visualize statistics, not explore statistics. We're going to visualize these statistics, by which it means it's going to open this lovely chart property window over here. And when my computer is done thinking very hard about it, it is going to show us the sum of all of these selections. So we can see right here that the sum is 24.2069, which if we are rounding to 2 decimal places would be 24.21 kilometers, which is the answer. Beautiful. Ta-da! Not too hard, I don't think. You can also do other if you have another method of getting to the sum that you like better, you can do that. Generally, this is my preferred method, is using visualized statistics. The only thing that I don't like about it is that it adds a chart over here in your contents pane, and I never want that chart. I always want it to go away. Alrighty, that was part 1. Let's move on, or it was part 2, but it was the first part. This was the part about the culverts, and we're done with that now. So I'm going to add a new map to work on the part 3, aka the Adirondacks part of this. And we're going to, wow, Arc is having a time here. And of course, the second map has put itself where I usually have my attribute tables, which I wouldn't personally do, but we're going to drag that right back up there. And now it's right here. So let's go into our practice part 3 data here and bring in all of our layers. Are we gonna, hello? What is the problem here? Is it the land cover descriptions? Oh, yes, it is. So as you just watched me try to do and fail to do, I'm not able to just bring in the whole container of the land cover descriptions because it is an Excel file. And Excel files can contain multiple sheets, and Arc only wants one sheet at a time. So instead, we're going to open it up, and we can see that in the land cover descriptions Excel file, there is a sheet called land cover descriptions. We are just going to bring this in. The $ means that it's a sheet. If you've ever done any cross sheet referencing in Excel, you'll know that that's what, well, that's not actually what the $ is used for. Ignore me. All right, so here we have our Adirondacks data for this part of the lab. So let's get started with it. We are interested in illegal logging using vector files. So this draws on a lot of the stuff that we used in our dead bird lab. We are interested in areas that contain hardwood as a land cover. So for land cover, we're looking at this land cover feature. We are interested in areas that are inside of the park boundaries. We are interested in areas that are between 0 and 100 meters of the road or between 100 and 200 meters of the road. So scroll on down here. The first question is about the projection of these data. You will not need to know this for the practical, but if you're curious and you want a little bit, stop it. And you want a little bit of a leg up on lab 6, we can do that by right-clicking on any one of these and going to the Properties tab, going down into the Source and Spatial Reference, and this will tell us that this data is in the projected coordinate system, NAD, which is the North American, oh my God, what's it called? Datum. 1983, this is based on data from 1983. UTM, which is Universal Transverse Mercator Zone 18N, which means that it is in the Northern Hemisphere and it is number 18. And you will learn all about that in Lab 6. So right now, don't worry about it. So question number one, we are interested. Well, that question number one was the projection. Question number two, how much land area is at highest concern for illegal logging? So hardwood land cover inside the park and within 100 meters of the road. So let's see. Wait, one second. Let me pause for 1 second because there's something weird happening. All right, my apologies. Sometimes you're doing this and you discover something. And the thing that I discovered is that the wording on the answer document needs to be updated because it's a little bit confusing right now because we are not, in fact, looking at the whole park. We are looking specifically at the town of Newcomb. So question number two, how much land area is at highest concern for illegal logging? So hardwood land cover inside the town of Newcomb and within 100 meters of the road. So to start working on this, we are going to work one by one through each of these criteria. So what we are interested in is land that has hardwood land cover, is inside of the town of Newcomb, and is within 100 meters of a road. So we're going to let's start at the top with our hardwood land cover. So we open up our attribute table for land cover. And that's not terribly useful. I don't know what any of these numbers mean. Luckily, I have this lovely standalone table over here called land cover descriptions that just might give me a little bit of help. So I open this up. Yes, hello, Mocha. Mocha says hi. Looking at this, we can see grid code number 1 is equal to hardwood. So looking at land cover, we know that anything that is number 1 right here is equal to hard cover. We want to make a new layer out of this for right now. So you can either select it like I just did by clicking on the row number. So just like that, like you would select a cell or a row in Excel, or we can use select by attributes, new selection where grid code is equal to 1. Hit apply. It's going to give you the same thing. Okay. And I'm now going to go into land cover and into data and create a new layer using the export feature tool using the selected record. So this is only going to give me our hardwood. Please take your claws out of my leg. Going to run that and it brings in a new layer that is just the selections from the land cover layer. So if we get rid of land cover, you can see, ta-da, that's all those things that were selected. So this is our new hardwood layer. This is showing us only hardwood. Next up, we are looking only at the town of Newcomb. So let's open up this towns file attribute table. We are looking for Newcomb. So I'm going to get a little lazy with it and I'm going to sort descending and then scroll down. Probably could have scrolled the other way. Oh well. To where it actually says Newcomb. There's another easy option here. Actually, I'll do this. This is actually probably easier. Go to select by attributes, New York Town, new selection. And the label is equal to, and then this time we're just going to type this in. That's easier. Are we? Newcomb? Hello? Newcomb. There it is. Alrighty. And hit OK. There we go, one selected. And oh my gosh, how convenient. It's right in the middle of our hardwood land file, our land cover file. So same thing that we just did with our land cover to get our hardwood. only layer, we're going to right click and go to data and export features. And again, we're interested in the selected records. And this is just Newcomb. Okay. All right, so now we have our Newcomb shape. You can see it's on top, so it's covering up a little bit of the hardwood. So let's get rid of New York towns for right now. We don't need that either. We just need these two things. And then the third criteria we are interested in is something that is within 100 meters of a road. So the roads go much farther than just Newcomb. However, if we were to clip to these roads just to Newcomb and then do our buffer, some of you discovered this with the Dead Bird Lab, we would end up losing a little bit of data or gaining a little bit of data in this specific case, but we would end up with little bulges at the outside here where we buffered because the buffer goes in all directions. So even if the road stopped right there, we would get another 100 meters out here. So even though it is a bit more processing intensive for matters like this, my general recommendation is to buffer before you clip. So we're going to go in, we're going to open up our buffer tool. Our input feature is our roads. That's what we are drawing a big puffy barrier around. The distance we're looking for is 100 meters. We would like for everything to be dissolved into a single feature because we are just interested. We're not interested in what road it is within 100 meters of. We are just interested in it being within 100 meters of a road. Side type full, end type round, planar. Yeah, great, perfect. And we're going to run. Oh, I didn't give it a good name. I'm going to rename it. Determining line connectivity. Beautiful, beautiful. And it's buffering. This might take a minute because we're buffering a lot of stuff. I'll pause it in the meantime. I literally clicked pause recording and it immediately loaded. So beautiful. So we can scroll in and we can see here is our line, this is our road, and then our 100-meter buffer around it. So I'm going to go ahead a little bit here. I'm going to jump ahead because we are already looking at these buffers. Actually, you know what? I'm not going to do that. I lied. So we have our three criteria right now. We have our hardwood layer. This is our layer that shows all of the areas that are primarily hardwood land cover. They look funky and square because these actually were originally raster files, which we will learn about more in Lab 7. You'll actually recognize Lab 7 if you're going through this. There's a lot of similarities. We have Newcomb, specifically, which is the town that we are the town manager of in our imaginations right now. And we have our roads and park buffer, our 100-meter buffer. Let me just rename that bad boy. Coming. All right. So we, in this case, are specifically interested in areas that are within these hardwood shapes, within this Newcomb shape, and within this road shape. So we are looking for areas that are in an overlap of all three of those. So we can simplify thinking about that a little bit by being like, okay, we're only interested in what's happening in Newcomb. So I don't need all of this hardwood information outside of the town. So if I think about all that hardwood information as some sort of, I don't know, cookie dough, it's really weird, messed up cookie dough, but I'm going to make myself a Newcomb cookie cutter. And I am going to clip this hardwood land cover data using my cookie cutter. And I'm going to keep what is inside of the cookie cutter. I'm going to keep the cookie, which means that it is a clip. If we were throwing away the cookie, it would be an erase. So my input feature is my dough, which is my hardwood. My clip feature is Newcomb. And my name for this bad boy is going to be Newcomb hardwood. Sorry if you're looking at how I name things. I go back and forth between underscores and camel case, depending on the vibes at that exact moment in time. All right, Newcomb hardwood. Let's get rid of this regular hardwood. Wow, and we can see that now we are only looking at areas of hardwood land cover that are within the shape of Newcomb. So we're halfway there. All of this blue stuff right here meets 2 of the 3 criteria for being high risk, in that it is both within the boundaries of the town and primarily hardwood. But all this stuff out here, that's really hard to get to. The places where we're actually really concerned about logging are places that are easy to access by way of logging truck. So that is anything that is along these roads in here, within 100 meters on either side, because that's a good estimate of where loggers, how far loggers might be willing to travel from the road. So once again, we can think about this like a cookie cutter sort of situation. So we have, again, our dough, that is the hardwood. That is what we are interested. We are interested in these areas of hardwood, but we are only interested in them where they overlap these roads. So we're going to create a really weird, messed up looking cookie cutter that looks like a bunch of worms that are all attached to each other. And we're going to use that on top of our big piles of also weird dough. So our input feature, our dough, is Newcomb hardwood. We are again using clip because we want to keep what is inside of the cookie cutter. Our clip feature, our cookie cutter, is roads 100-meter buffer. And our output is called high risk because it meets all 3 of those high risk criteria. It is inside of Newcomb, it is primarily hardwood land cover, and it is within 100 meters of a road. Why is it being mad at me? Okay, it's done being mad at me. All right, run. And we think, and we think, and we think, and beautiful. It's hard to see because it comes in the same color, because Arc is a good and normal piece of software that makes it easy to understand things. So let's make it bright green. Hey, there we go. So we can see that all these bright green areas, as they should be, are within the boundaries of Newcomb. They are within these weird pixelated blue land cover areas, and they are within the road buffer. So that tells us on visual inspection, okay, it makes sense that these are our areas of highest concern because they only fall within those 3 criteria. So now if we want to know about the area of these, we can go right in here, and it says shape area. Never trust this. Just don't do it. So we can go in and add a new field. The field is area KM. It is going to be float because we are interested in decimal places. Big integer. That's a very funny name. Can I read? Yes, I can. I was distracted by big integer. Save. And back over to here. We are going to calculate the geometry. Area kilometer. We are interested, of course, in the area. Beep, beep. And the area unit is going to be square kilometers. Again, do not worry about the coordinate system. We are looking at a small enough range that we don't need to worry about the curvature of the Earth. Okay, or approximations thereof. Hey, and our answer is 1.388 square kilometers. If we were to round that to 2 decimal places, like the answer guide does, you would end up with 1.39 kilometers, which is the right answer. All right, the last question. Well, the last question is describe how you got the answers to these, but that's what you just watched for the last 10 minutes or whatever. So, last question. How much land area is it moderate concern or medium concern for illegal logging. So in this case, we are still interested in hardcover, and we are still interested only in the town of Newcomb, but we are expanding the range around the roads that we are considering at risk. So rather than just the area that is between 0 and 100 meters from the road, we are interested in the area that is between 100 and 200 meters of the road. So to get started on that, we're going to go back to our roads in park and buffering. Let's move this back on top so we can see her. So there she is. And you can see this buffer, so that's 100 meters on either side. So that is our area of high risk. Not clip, we want buffer. Buffer. Okay, so our input features, again, roads in park. We are using the full road so that we don't end up with anything funky over here. And I'm gonna name it this time. This time it is called roads underscore 200 meter buff, because we are going to do our 200. In order to only have between 100 and 200, you need both the 100 and the 200. We're dissolving everything in there and everything else is fine. Let's run that. And I really made a fool of myself last time by pausing for exactly 1 moment. So this one maybe will take longer, but we are going to end up with another buffer that is roughly twice as wide as this one. What we want to do is end up with a shape that is only the area of the 200 meter buffer that is not also covered by the 100 meter buffer. So we can use our cookie cutter analogy again. If we think about our 200 meter buffer, all right, so our 200 meter buffer is our dough. We want our final product to include just the area that is covered by that, but is not covered by the 100 meter buffer. So we're going to use the erase tool, because if we, again, think about the 200 meter as our dough and the 100 meter as our cookie cutter, we are not interested in keeping the inside of the cookie. We are only interested in the dough that is left behind. So let's go in for our erase tool. Our input features, again, is our 200 meter buffer. That is our dough. Our erase features, our cookie cutter is our 100 meter buffer. And we're going to call this roads medium risk, because I don't want to write out 100 and 200. Mocha, what are you doing? Stop that. She's causing problems. What are you crinkling? Stop crinkling things. Stop it. All right. It is updating. Oh, I spelled roads wrong. Don't worry about it. Where is it? Oh my God, someone's dog is making a bad noise. What on earth? Okay, well, ignoring that. So if we get rid of our 200 meter buffer, you can see that these fit perfectly like a cookie cutter. So it's the 200, so you can turn that back on. It's all darker blue because it all overlaps. But if we turn off these two, you can see, oh, awesome. So we now have a shape that is only the distance that is between 200 and 100 meters from the road. Anything that is in here, aka that high risk stuff, which we can see these little green squares, that stuff is not included here. That is our high risk. We're now interested in medium risk. So just like we did for our medium risk, nope, just like we did for our high risk, we are now going to use another clip. So we have our dough, that is our hardwood within Newcomb. And we have our cookie cutter, which is this blue area that is within 100 and 200 meters of the road. So it is accessible to illegal loggers who are on the road, but they have to walk a little bit farther. So they're less likely. It is at a slightly lower risk because it is less easily accessible. So that is our cookie cutter. We are interested in areas like this, which are both hardwood inside of Newcomb and within this blue barrier. So we're going to go back to our clip tool. because we are keeping the cookie. We are interested in the cookie that is left over in here. Our input feature is our hardwood. That is what we are interested in here. And our clip feature is Rad's medium risk, because I can't spell. So this is just going to be called medium risk. Beautiful. And run. And there we go. We can see them right there. There's a little guy right there, but it's still that same blue. So let's make it not blue or electric green. Let's make it pink, bright pink. There we go. Beautiful. And we can scroll out and we can see that these pink areas indeed are only within this blue buffered area. They are also only within the hardwood areas and only within Newcomb. So just like we did with our high risk, in order to find our area of effect, we're going to ignore whatever's happening there. Is that the number that I want? Uh-oh. We'll see. We're going to add a new field. And it is called area kilometer, and it is a float. And save. Uh-oh. I did do something wrong. Oh, I used hardwood instead of not hardwood. Haha, I was going to say, why is there pink out here? All right. Let's do this again real fast. So going back to geoprocessing, there's our issue. I used hardwood instead of Newcomb hardwood. So let's redo this with Newcomb hardwood. It is still medium risk. We're just going to overwrite that previous file. I was looking at that number and I was like, that's not correct. All right. But this is a nice thing to know, is that if you mess up like this, you can simply just rerun it with the same file name and it'll give you this little warning. It's like, something's already called that. And I'm like, yeah, I know, and it's wrong. So I'm going to redo it. All right. Those pink areas from out of here are gone. But if I scroll in here, oh yeah, they're blue, not pink again. I'm going to make them pink again. Wow. And pink, bright. Ha, there they are. And now they are only within Newcomb. So let's try this again. We did add that new field to medium risk, so that is still there. Where is, oh, I deleted it, so the attribute table went away. Open this bad boy up. Okay, that looks much more reasonable. We are going to have to add the field again. So area, kilometers, era. I cannot spell today. Is it going to get mad at me because I already have something? Oh, it is in there. I can't read, y'all. No, it's not. What? Something strange has happened and I can't see it in here, but this tells me that it is in here and that it's visible, but it's not. So we're going to call it area KM squared and save. Okay. There we go. It's lying to me about that other area field. So as we did before, we can calculate our geometry. Area kilometers squared in the medium risk. We're interested in area. And we are interested in kilometers squared, square kilometers. We don't need to worry about the coordinate system. Hit OK, and it's going to do our calculations. And 1.3 kilometers squared, which is the correct answer. So something that I did just want to point out, because I know I get a lot of questions about this, is some of you might be looking at this shape area and this area kilometer squared and being like, well, Ollie, actually, I can very clearly tell that this must be square meters and this is square kilometers. To which I say you are correct in this one case, because this is in meters. The map coordinates themselves are in meters. That is what ARC is going to use. That is not always the case. You can change how the projection is shown. You can change what, I can go in and say, all right, decimal degrees, or I can go in and say, all right, US feet. And if I had done that and you were like, oh, I see that this is US feet and this, so this shape area must be square feet. Incorrect. Do not ever trust these shape, length, shape, area fields. They love to betray you. They might be right, even most of the time, but the times that they are wrong, you do not want to have that be happening to you. So always calculate your own geometry. And yeah, there you go. So that was, I in my brain estimated that it would take a half an hour, and that was definitely more than a half an hour. So thank you for sticking around with me. Let's stop my share. And here. Hello. I'll show you my cats since you stuck around for this long. Wow, come here, baby. Oh my god. She's having a problem. She's having a problem. Bye. And her having a problem scared my other cat away. So you get one cat. All right. Good luck on the practical on Thursday/Friday. Denny will be proctoring the Thursday practical. I will be proctoring both the Friday practicals. We're just gonna be there and vibing in case there's like a big problem, but we will not help you if there is a less big problem. So, Godspeed. Y'all got this. Watch through this again if you need. You can always email me, Denny, or Forrest with any questions. Forrest may or may not email you back because he is not feeling well. But I think that is everything. Oh, wait, here. She came back. Hi, baby. Wow. Here's the other kitty. She's less angry. She lets me give her kisses. Mocha would never let me give her kisses. That was Magma. Mocha was the angry one. All right.